Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video, we will study about the special function registers or SFRs of 8051 microcontroller. So let us start with our topic. In 8051 microcontroller, there are 21 internal registers which are known as the special function registers. The use of these special function registers is to control the timers, counters, serial input-output ports and input-output ports of the 8051 microcontroller. So these special function registers, they occupy some memory locations in the memory of the 8051 controller, and they will have some specific functions according to the name given to them. So let us study about these special function registers in detail. So 8051, it has 21 internal registers which are known as the special function registers, and these SFRs, they are used to program and control the different peripherals like the serial input output ports and the timers, counters. So all these peripherals, they can be programmed and controlled using the special function registers. Also the SFRs, they act as the control table that monitor and control the operation of 8051. Because the programming of the 8051 or operation of 8051, it deals with the working of the peripherals also. So peripherals are all controlled by these SFRs. So we can say that this SFR, it also controls or monitors the operation of 8051, that is in which mode it is going to operate and how it is going to operate or work, that is decided by the special function registers. So each register of the special function register group, it has one byte of address and a unique name which specify its purpose. So every register will have an address and a unique name is associated with that special function register. So each SFR will have the unique address, means address will be associated with it and a unique name will be given to it, through which we can see that what is the function of that special function register. Now these registers, because they have addresses associated with it, so there are some registers which are both byte addressable and bit addressable. Here I have written that each SFR is having 1 byte of address. So if we want to address that SFR, we can use bit addressing also and byte addressing also. So these registers, they are both bit and byte addressable. Now 8051 microcontroller, it has 256 bytes of internal RAM, and this RAM, it can be addressed by using the 8-bit addresses. So for 256 bytes, we will have the 8-bit addresses in the range from 00H to FFFH. Means 000H to FFFH, we will have the addresses. Now out of these 256 bytes, we are dividing it into two, that is 128 bytes and again 128 bytes. So starting 128 bytes, that is first 128 bytes, they are assigned to or allotted to the internal RAM. So the addresses will be from 00H to 7FH. Okay. And the next 128 bytes, they are assigned to the special function registers. So next 128 will be from 80H to FFH. Okay. So this is how the total 256 bytes, they are divided. 00 to 7F for the internal RAM and 80H to FF for the special function registers. If we describe it in the form of a diagram, then suppose this is the total 256 bytes of internal RAM. 00 to 7F, it is the internal RAM, and 82 FF is the special function registers. Okay, so this is how the total 256 bytes are divided. Now if we want to access these special function registers, if we want to program or use them in our program, then we can use the move instructions. Using MOV move instruction, the special function registers can be accessed. Okay. Now let us see that as I have told that 8051, it has 21 special function registers. So let us see that what are these 21 special function registers, SFRs. Now these SFRs, they are divided into different categories. Like first category we have is the math or CPU registers. Means total 21 SFRs, they are divided into different categories. First category is the math or CPU registers, in which comes the A and B registers. A register is the accumulator and we have B, which is the general purpose register. So these two registers are special function registers and they come under the category of math or CPU registers. Second category we have is the pointer registers. There are two pointer registers. One is the data pointer and second is the stack pointer. Data pointer is DPTR and stack pointer is SP. Okay, this is the specific or the unique name what I have told earlier, and through this name we can see it indicates also that what is the function of that register. Okay. Third category we have is the status registers. Under this comes the PSW, that is program status word. PSW. Next category we have other input output port latches. Under this we have port 0, port 1, port 2 and port 3. So these four registers also come under as the special function registers. Fifth we have peripheral control registers. Under this category we have PCON, SCON, TCON, TMOD, IE and IP. These registers, they come under the category of peripheral control registers. PCON, that is power control, SCON is the serial control, TCON timer control, timer mode, interrupt enable and interrupt priority. Sixth we have peripheral data registers. Under this category we have TL0, TL1, TH0, TH1. These are for the timers. Higher and lower bits are there for timer 1 and timer 0. And we have SBUF, that is serial buffer. So these are the total 21 internal registers, SFRs, which are divided into different categories. You can count here, we have the total 21 registers there, and the addresses of these 21 registers, it lies between the address range 80 to FFH. Each register will have a specific address, so instead of writing that register, we can write the address also, so that address is assigned to that special function register. Now let us study the function of these registers in detail. First we will start with the math or CPU registers, that is A and B registers. So A and B registers, as I have told, that these are the math or the CPU registers, and they are usually used whenever the microcontroller, it performs the CPU or the arithmetic and logical operations. So the use of this comes whenever the microcontroller, it performs arithmetic operations like addition, subtraction, multiplication, division, and logical operations like logical AND, OR, NOT, XOR. So in that cases, the A and B registers, they are used. Now out of this we have A. This A register, it is the most popular and the most used, most important, we can say, most important register of the 8051 microcontroller, because this register, it is used to store the result of the ALU operations. Whatever arithmetic and logical operations the 8051 is performing, the result of all those operations will be stored or accumulated in this A register. That is why this A register, it is also known as the accumulator. So this A register, it is also known as the accumulator because it stores the result of all the arithmetic and logical operations. So these A and B register, they are the 8-bit registers, because 8051 microcontroller, it is dealing with 8-bit data. So that 8-bit data, whenever ALU operations are performed with it, so that result will be stored in the accumulator. Okay. Now what's the use of this B register? This B register is used in combination with this A register whenever 8051 performs the multiplication and division. Because in the case of multiplication and division, the result, it can be either more than 8-bit data, the result can be either 16-bit data can be there. So to store that 16-bit data, we use A and B register in combination. Okay. And for division, we require a divisor and the dividend. So one content will be stored in the B register and one content will be stored in the A register, and then the division operation will be performed. So B register is used to perform the addition, the multiplication and the division operations. So this was the A and B register, which come under the category of CPU or the math registers. Next, SFR, that is a special function register, is the data pointer. This data pointer register, its mnemonic is DPTR. Okay. And this data pointer register, it is a 16-bit register. But it can be used as two 8-bit registers also. So it will have the total 16 bits, and those 16 bits, they can be divided into higher order bits and lower order bits. So if we say that it is having 16 bits from D0 to D15, then higher order bits will be, higher order data pointer register will be called DPH and lower order will be called DPL. So lower order will have D0 to D7 and this is D8 to D15. Okay, so 16-bit register, it can be used as two 8-bit register, higher order and lower order. The total 16-bit register, it does not have any address associated with it, but the two 8-bit data pointer registers, higher and lower, they have the addresses. So DPH, it is having the address 83H in the memory, and DPL is having the address 82H in the memory. So in the total memory of the special function register from 80H to FFH, DPH will be at the position 83H and DPL is at the position 82H. Okay, so this is the addresses of the data pointer register. Now what is the use of this data pointer register? Whenever the 8051 microcontroller, it is dealing with the external memory or the program memory, then this data pointer register is used to point towards the memory location in the external RAM. Okay. So this data pointer register, it is used in operations regarding the external RAM and also some instructions involving the program memory. Now this is a 16-bit register, so it's the range of values it can take is in the range from 0000H to FFFFH. Okay, because it is 16-bit, means 2 bytes are there, 1 byte for DPH, 1 byte for the DPL. Okay, so it can take the values from the range 0000 to FFFH, or we can say in the form of decimals, if we say 0 to 65535 values it can take. Okay, so this was the data pointer register. Next, a special function register is the IE, that is interrupt enable. The address of this SFR is A8H. Okay, so in the memory location it will occupy the address A8. Now, what is the use of this interrupt enable register? This register is used to enable or disable all the interrupts of 8051 microcontroller. This register will have 8 bits, and out of those 8 bits, the lower bits, they are used to enable or disable all the interrupts, whereas the most significant bit, that is the D7 bit, it is used to enable or disable, lower 7 are used to enable or disable particular interrupt, but D7 is used to enable or disable all the interrupts of 8051. So we can say that interrupt enable, it is used to enable or disable the interrupts. So it will have the 8 bits, and out of those 8 bits, the lower 7 bits, these are used to enable or disable the specific interrupts, but the most significant bit, it is used to enable or disable all the interrupts. So if we draw here the 8 bits, so this is going to enable or disable all interrupts, and these are for the specific interrupts. Now in this interrupts, we can say that if this bit, okay, if this bit is 1, then all the interrupts will be enabled. Okay, and if any of the bit in this these 7 bits, if any of the bit is 1, then that specific interrupt will be enabled. If we want to disable it, then its bit will be made 0.
क्रॉस में जा रहा है तो
अभी तो कहाँ क्रॉस में है?
दिख रहा है
अरे बाबा, नहीं तो मैंने सीधा ही लिखा. ठीक है, चलो देखती हूँ. This video is in content. सी में start करूँ. So if the bits are 1, then the interrupts will be enabled, and if the bit is 0, then the interrupts will be disabled. So that is the interrupt enable register. Now, if any of the bit here, if the bit is 0 and any of the specific interrupt bit is 1, then also that interrupt will be disabled because this bit is 0. So this bit has to be 1 if we want to generate any interrupt in 8051. Okay, but because if this is 0, then all the interrupts will be disabled regardless of the condition of the specific bits of the interrupts. Next register we have in the special function category is the interrupt priority register, that is IP. The address of this interrupt priority register is B8. Now this register is used to decide the priority amongst the interrupt. When 8051 it encounters interrupts, means more than one interrupt is given to 8051, then how it is going to decide the priority, that first it has to acknowledge this interrupt, after that second number, third number. So how the priorities is decided, that is decided by the interrupt priority register. This register is also an 8-bit register in which all the interrupts, they will have a specific bit. So if that bit is made 1, means that interrupt will have the highest priority. Okay, so in this way the priority levels are decided in 8051. So this IP register, it is used to specify the relative priority of each interrupt, that which interrupt is having highest and which is having the lowest priority. So an interrupt, it may have high or the low priority. Okay. Now an interrupt, it may only interrupt interrupts of lower priority. Suppose that we are having 7 interrupts. Out of those 7 interrupts, we are having an interrupt called serial interrupt, which is having the highest priority. Okay, and we are having the rest of these 6 interrupts. So the remaining 6 interrupts, they will have the lower priority than the serial interrupt. Now if this serial interrupt is given to the 8051 microcontroller, so 8051, it will first execute or first acknowledge this serial interrupt, and all the interrupts, they will be masked, and after that according to the priority, remaining will be executed. So an interrupt, it may only interrupt interrupts of lower priority. Okay, suppose that any of the interrupt among these 6 interrupts is given. Okay, suppose its name is XYZ, so XYZ interrupt is given to 8051. Now at the same time, the serial interrupt is given to 8051. So serial interrupt is having higher priority, so XYZ will be masked and serial interrupt will be executed. So here an interrupt, it may only interrupt the interrupts of lower priority. This XYZ, it is not going to interrupt the serial interrupt because it is having the highest priority. So first that will be executed, after that XYZ will be executed. Okay, so in this way priorities is decided. The interrupt which is having the highest priority, that will be first executed by the microcontroller. Okay, so this register, it is used to specify the relative priority among the interrupts. Next is special function registers we have in the category of input-output ports. So in the input-output ports category, we have P0, P1, P2 and P3. The 8051 microcontroller, it is having 4 ports and each port is of 88 bits. So we are having 4 ports and each port is having 8 bits. So we will have 32 bits of the total 4 ports. Okay. So first we will start with the P0. Okay. This is the P0 register and it is for port 0. Its address is 80H. Now each port is of 8 bits and these 8 bits are specified as P0.0, P0.1, P0.2, so these are the 8 bits of port 0. For port 0 we have P0 in front of all the bits and these denotes the 8 bits. Now in this P0, this input output port, each bit of this SFR so this special function register P0, it is also of 8 bit. So every bit of this special function register, it corresponds to the 8 bits or 8 pins available on the microcontroller. So if we are having these 8 bits here, that is from D0 to D7. Now if any of the bit, it can take either the value 1 or it can take the value 0. So if it is 1, means suppose this is 1, so that bit is corresponding to, this is D1, D2, D3, D4. So corresponding bit will be P0.4, so that pin will be made high. High means that that pin will be made the input port. Okay. Suppose any of the bit here D5, D6, suppose that D7 is made 0. So corresponding bit is what? P0.7. So that bit will be made low. Low means that that pin will act as an output pin. Okay, so here I have written that each bit of this SFR, it corresponds to one of the pins on the microcontroller. So 8 bits of this P0 SFR, it corresponds to the 8 pins of port 0. Similarly, we have P1, P2, P3. These 3 registers are also there. P1 is for port 1. Its address is 90H. P2 is for port 2. Its address is A0H. And P3 is port 3 and its address is B0H. So P1, it will also have the 8 bits and these bits corresponds to the 8 bits of the port. So P1.0 to P1.7. Similarly for P2.0 to P2.7. P3.0 to P3.7. So if any of the pin we want to make it as an input pin or an output pin, that can be done with these special function register P0, P1, P2 and P3. Now when the 8051 microcontroller, it is reset, then upon resetting all the pins of all ports, they are set. Set means their value is made 1, and when they are set, it means that they are configured as an input pins. Okay, so when the 8051 microcontroller it is reset, then all the ports they will be initialized as the input ports. Okay, so this was the input output ports P0, P1, P2, P3. These are the 4 special function registers under this category. Next we have is the power control register, that is PCON. It is denoted as PCON, also known as PCON, and this register is used for the power control and the baud rate selection in the 8051. So this power control register, it is again an 8-bit register. So all the 8 bits of this register, they will have some specific functions, and these functions are related for the power control and for the baud rate selection. Let's see the format of this power control register, PCON. Now as this is an 8-bit register, so it will have the 8 bits from B0 to B7. Now these 8 bits, the name of the register is power control register. Okay, so this register is used for the power control. In this we have the 2 bits, one is the power down and one is the idle pin. Okay, so when this microcontroller, when this bit is set, this is for the idle mode bit. So when this bit is 1, then this mode is activated, and when this is 0, then this mode is not activated in 8051. So this B0 bit, it is for setting the idle mode. In this idle mode, the clock signal provided by the 8051, that clock signal is not provided to the CPU, but it is provided to other peripheral devices like the timers and the serial ports. To all them, clock signal will be provided, but to CPU it will be stopped. So we can say that in the idle mode, when the clock signal is stopped to the CPU or the arithmetic and logical unit, so all the operations they will be stopped by the all the arithmetic and logical operations performed by 8051, they will be stopped. Means the 8051 it enters into the idle state, but the functioning of the interrupt, timer and the serial blocks, it will continue as it is because no supply is cut off from these blocks. Okay, so that is the idle mode. So this idle mode is set by setting this B0 bit to 1. Now if we want to reset this mode or if you want to terminate this mode, then it can be terminated by either an interrupt or by hardware reset. That is, by resetting the 8051 or by giving an interrupt, we can terminate the idle mode. So this was the B0 bit. Now we have the B1 bit, which is PD, that is the power down mode. Now 8051, it operates at the power supply of plus 5 volts. When this bit B1 bit it is set, means its value is equal to 1, then the 8051 it enters into the power down mode, and in this power down mode the power supply is cut off from 5 volts to 2 volts. Okay, so power is reduced, that is why it is called the power down mode. Now when this power down mode it is set, then the internal oscillator, how this power is reduced, the internal oscillator is stopped. Internal oscillator, it is the feature of 8051 that it has an internal oscillator connected in it. So this internal oscillator it provides the power supply to all the other components. So when this when this bit PD bit in this Econ register it is set equals to 1, so the power is reduced to 2 volts, that means the internal oscillator is stopped. Now how it can be terminated, this power down mode, again by a hardware reset. Now next bit in this Econ register we have B2 and B3. These two bits are used for the general purpose flags, like the user can define these flags. So we can say that these two bits are for the general purpose flags. Okay, so these flags are used to indicate the conditions when the program is executed. So programmer can use these flags to indicate the status of various conditions. Okay, there are two general purpose flags, GF0 and GF1. Bit B4, B5, B6, these bits are not defined in this register. Next we have bit number 7, that is the most significant bit, which is called the S mod. Okay, S mod means the serial mode selection. Okay, so this serial mode, in this mode it is used to decide the rate in the serial communication, that is at what speed the serial communication is done by 8051, or we can say that rate is called the baud rate. Baud rate means the bits which are transmitted per second. So baud rate is decided by this S mod bit. Okay, so we can say bit number S mod bit The serial ports of the 8051 microcontroller, they operates in 4 modes: mode 0, mode 1, mode 2 and mode 3. Out of these 4 modes, the 3 modes, mode 1, mode 2 and mode 3, in these 3 modes the baud rate is selected by modifying the bits of the serial register. Okay, so this S mod bit in this Pcon register, it is used to decide the baud rate in the serial port operating modes 1, 2 and 3. How it is deciding the baud rate? Let's see. In mode 0, sorry, in modes 1. So in mode 0, the baud rate is fixed. In mode 1 and 3, this S mod bit is used to decide the baud rate. How we can find out the baud rate? So both the SMOD bit and the timer 1 overflow flag, they are used to find out the baud rate. So baud rate will be equal to twice of the SMOD bit, that is whether it is 1 or whether it is 0, divided by 32 into timer 1 overflow flag. What is the status of that flag, whether 1 or 0. So that will be the baud rate in mode 1 and 3. Next we have mode 2. Now in mode 2, if this SMOD bit is equals to 0, then baud rate is 1 by 64 of oscillator frequency. Whatever frequency is provided by the oscillator, we will take 1 by 64 of that frequency, and that will be the baud rate. Now if SMOD is equals to 1, then baud rate is equal to 1 by 32 of the oscillator frequency. So this is how this SMOD bit, it is deciding the baud rate, okay, in mode 1, 2 and 3. So we were studying the PCON register, that is power control register, which is used to select the modes, either power down mode or idle mode, and also to select the baud rate. So these are the 8 bits, how the 8 bits of the PCON register, they are specified, okay. Next register we have in this special function register category is the program status word. Its short form is PSW. This program status word register, it is also known as flag register, and flag register is used to indicate the conditions of the program, means what the result obtained after the execution of the instructions. So whether the result is generating a carry, an auxiliary carry, or an overflow is generated. So all that conditions are specified by the flags. So we can say program status word, it is also known as flag register. So program status word, this register is also called the flag register, and these flags are useful for the programmer to test the conditions of the result and make decisions. Suppose the 8051, it has performed some arithmetic operation like addition is performed, and when two 8-bit numbers they are added, then the result which is obtained, that is greater than the 8 bits, mean a carry is generated. So this carry will going to set the carry flag. So if the programmer, it tests the carry flag, checks the carry flag, and if the programmer finds that the carry flag is set, so it will get an idea that when this arithmetic operation is performed, then carry is generated. So it is useful to test the condition of the result and to make the decisions. Now these flags, they are 1-bit storage elements. Only 1 bit is stored. Either it will be 0 or it will be 1. When it is 0, it means the flag is reset, and when it is 1, it means the flag is set. So whenever that condition appears, like carry is generated or overflow is generated, auxiliary carry is generated, so at that time that particular flag will be set, otherwise it will be in the reset condition. So these are 1-bit storage elements that store and indicate the nature of the result, that what type of result is generated, and that means that condition is generated due to the execution of certain instruction. So if addition, add instruction, due to that add instruction carry flag can be generated. Okay. Also, if we are having some logical instruction like AND operation is there, logical AND is there, and if you want to find the parity also, and if the result is having even parity, then this flag will be set. Okay. Now this program status word, this flag register, it is of 8 bits. So let's see that what the 8 bits of this program status word it specifies. So these are the 8 bits of the flag register. This CY means MSB, most significant bit, it is for the carry flag. Auxiliary carry. This F0, it is a user defined flag. These RS1 and RS0, these two bits are used for selecting the register banks of 8051. In 8051, we have the 4 register banks, bank 0, 1, 2 and 3. So these 4 register banks, they can be selected using the 2 bits. They can be 00, 01, 10 and 11. So when it is 00, then bank 0 is selected. If it is 01, then bank 1 is selected. If it is 10, then bank 2 is selected. If it is 11, then bank 3 is selected. So these 2 bits are for the bank selection. Then we have OV, which is for the overflow flag. This B1 bit, it is reserved for future use, and bit B0, this is for the parity flag. So depending upon the result obtained after the execution of the instruction, these flags are set or reset. Okay. So this was the program status word, because it is indicating about the status of the program. That is why it is called program status word. Next register we have is the SCON. SCON, and its full form is serial control. This register is used to control the operation of the serial ports. These serial ports, they can operate in different types of modes. So those modes are decided by the SCON register. So this SCON serial control register, it is used to control the operation modes of serial ports, in which mode the ports are going to operate, also the baud rate of the serial port, and these serial ports, they are also used for the receiving and transmission of data. So send or receive using these serial port is also decided by this SCON register. Again, it is an 8-bit register. So the 8 bits, they are specified as so SM0, SM1, SM2, this decides the modes of the serial ports. REN, it is for the baud rate selection. Then we have the last 4 bits, these are for the transmission and receiving of the data. So these are the 8 bits of the SCON. Now this SCON register is also contains flags which are set or reset depending upon the condition that whenever a bit it is successfully sent or received by 8051. So when the bit is sent means it is transmitted, so T1 flag will be set, and when the byte is received then this R1 flag will be set. So it is having the flags which are set when a byte is successfully sent or received. So this was the serial control register. Next register we have is the serial buffer. Its short form is SBUF. Now this register, it is used to hold the serial and the parallel data for the transmission. Whenever 8051 it is doing the serial communication, so serial and parallel data is available with it. So to store that data we have the data buffer register. So this register is used to hold So it is used to hold the parallel data during the transmission and the reception. During the serial reception means when the serial data is received, so that serial data is received via the RxD pin of 8051, and that serial data is converted into parallel data. Okay, so this parallel data, when it is serial is converted into parallel, after that it is stored in the SBUF register, serial buffer register. Now during the serial transmission, because the 8051 it is having the parallel data, so parallel data is converted into serial data, and after the conversion this serial data is stored in the serial buffer. So we can say that the serial buffer is used to store the parallel and the serial data during the transmission and the reception. So because for transmission and reception we are using the same buffer, serial buffer, so transmit and receive they are assigned the same address. So how it is decided that this is the transmitted data and this is the received data? That is done that when the data is written to the serial buffer, it goes to the transmit buffer, and when the data is read from the serial buffer, it goes to the received buffer. Okay, so this is how the transmitted and received data they are classified. Next register we have is the stack pointer. This stack pointer register, it is also and pointer register just like the data pointer, and it is used to point towards the 8-bit address of the top of the stack. Stack, it is the temporary memory location in the RAM of 8051, and that temporary memory location, that is the stack, it is used to hold the temporary data, and subroutines for the interrupts all are stored in the stack. So this stack pointer, it points towards the 8-bit address which indicates the top of the stack. So for this stack pointer, it holds the 8-bit address of the top of the stack, and any portion of the RAM, it can be reserved for the stack. Out of these 256 bytes, any location, any memory locations, they can be assigned for the stack. Now when the 8051 it is reset, then the stack pointer, it is initialized by the value 07H. Okay, so that will be the starting address of the stack when the 8051 is reset. Now if we want to store or retrieve the data from the stack pointer, means this is the stack. Here the stack pointer is initialized. So from this memory location, the data is going to be stored. The stack will start. Now if we want to store the data, we will use the instruction push, and if we want to retrieve the data from this, we will use the instruction pop. Now when the data is stored, stack pointer is initialized at this memory location, so stack pointer is incremented by 1, and then this data is stored at this memory location. Now when we retrieve this data, then stack pointer is decremented by 1, because when this data is stored, now the stack pointer will point to this memory location, because this is the top of the stack. Now when this data is to be retrieved, again the stack pointer has to be decremented. So for the push instruction, the stack pointer is incremented by 1, and for the pop instruction, the stack pointer is decremented by 1 automatically. Okay, so we use push and pop to store and retrieve the data from the stack, and this stack is used to hold the temporary data and the programs like subroutines. Okay, next special function registers we have are the tmod and tcon. These registers are for the timer operations. Tmod is for the timer mode, and tcon is for the timer control. Both these registers are 8-bit registers. In 8051, it is having two timers. Now these timers, they are 16-bit timers. Timer 1 and timer 0. Now these timers, they can operate in different modes like mode 0, 1, 2, 3. Okay, so those modes are decided by this tmod register. Okay, that is an 8-bit register, so those 8 bits will decide the modes of operation of these two timers. And this tcon register, it controls the status of these timers. Okay, like if we want to see that whether the timer is overflowed or not, and whether the control bits of the timers, all is decided by this tcon register. So we are having two timers, and these timers, they can act as counters also. We can say that these are counters also. So whether they will operate as timer or counter, that is also decided by the tmod register. Okay, if we see its 8 bits, so these 8 bits, the upper 4 bits are for timer 1, and the lower 4 bits are for timer 0. This is the gate bit. This is for timer 1, this is for timer 0. So this gate bit, it is used to start or stop the timers. Means when this bit is 1, then timer is going to start, and when this bit is 0, timer is going to stop, or we can say the counting will stop. This second bit C and T, C C bar and T, this is to decide that whether the timer it will act as a counter or as a timer. So when it is 1, it will act as counter, and when it is 0, it will act as timer. Then these two bits are for deciding the modes of the timer, whether it will act in mode 1 or mode Z. These two bits, they can take different values, 0, 0, 0, 1, 1, 0 and 1, 1. So we are having 4 modes: mode 0, mode 1, mode 2 and mode 3. So for timer 1 we have these two bits, and for timer 0 we have these two bits. Okay, so this was the T mode timer mode register. For TCON also we have the 8 bits which decides the overflow flag and the run control flag for timer 1 and timer 0. Okay. Next we have the special function registers as TL0 and TH0, and we have TL1 and TH1. This is for again for timer 0, and this is for timer 1. Now as I said that these two timers, these are 16-bit timers. Okay, so 16-bit timers, they are divided into 8 bits, TL and TH, that is timer lower and timer higher bits and lower bits. So for timer 0 we have TL0, TH0, that is timer lower, means timer 0 lower bits and timer 0 higher bits. Similarly for timer 1 we have timer 1 lower bits and timer 1 higher bits. Okay, so these are the 8-bit registers which corresponds to the 8 bits of the respective timers. Now these bits, if we collectively take them, then it will form the 16-bit timers. So we can load the count value into these timers, because timers can act as counters also. Okay, so we can initialize the count value by loading the count into these registers, and after that the timer will start the counting operation. Okay, so these were the timer registers. So in this video we studied about the various special function registers of the 8051 microcontroller. We studied that the 8051, it has 21 special function registers which are having 1 byte of address. Some registers are both bit addressable and byte addressable, and these special function registers, they are categorized in different categories. Some are the CPU registers like A and the B registers. Some are for the pointer registers like the stack pointer and the data pointer. Some were for the serial input output ports, and input output ports were also there, P0, P1, P2, P3, and peripheral control registers are also there, and peripheral data registers are also there. So we studied about all the registers in detail in this video. So I hope that this topic is clear to you. Thank you.